Hello and welcome! Today I'll be showing you how to build a solar system using the Real Solar Systems mod. This tutorial will not cover every single feature in depth, but we will be using most of the features for this build in some form. To start, subscribe to the Real Solar Systems empty world on the workshop and make a new file. This world has the core mods already installed and has the sunlight plane fix for real stars. You can also just use the vanilla star system world, delete all of the planets, and add the mods yourself. But don't use the vanilla empty world or the sunlight will be crooked. We're also going to add the Vibrant Skins pack for real gas giants, so we have a few more gas giant skins. Load back in and open the editor with /TSE. We'll start off by adding a gas giant body. If you want to use any MES mods with your world, you'll want to make sure your systems are away from the world origin. Moving everything up by 100,000 kilometers is usually good. Let's make this one a black hole by changing the planet and ring skins. Next, we can adjust the ring visuals. Now we can add a star as a sibling. Siblings are bodies that orbit each other. Normally, child bodies are set to orbit parents, but siblings will both move. This is useful for creating things like binary stars. In the hierarchy list on the left of the screen, you can identify siblings by the circular arrows connecting them. We'll adjust the sibling orbit by looking in Edit Orbit Info. The sibling orbits are controlled by the orbit options of the second sibling. The first sibling controls the orbit of both objects around whatever parent they might have. This needs some decoration, so we'll add a particle effect to the star. Let's get it facing the black hole so the star is being eaten. Most particles point up by default, so you may have to set the pitch to 90 or -90 to have it point sideways. A good start, but I think we can improve it. We can modify a lot about how the particles behave with the options here. Try experimenting to get the look you want. Be careful about setting spawn mult or life mult too high, or your GPU will be sweating. Looks good. Let's add another body. This time, we'll add a planet as a child to orbit the black hole and star. Now that we've got a new Earth-like to work with, let's adjust the orbit. Semi-major axis is the main radius of the orbit. Eccentricity controls how elliptical it is. Pitch, roll, and yaw rotate the orbit. Orbital period controls the duration of the orbit. The speed readouts at the bottom tell you how fast the body is moving. Let's add a ring to this one as well. One or more rings can be added to any planet, gas giant, or star. They define a flat region around the body where asteroids, resources, and weather particles can be configured to appear. Planet skins can be used to change the appearance of the planet proxy. This is entirely cosmetic, and planets should generally be set with a proxy that matches their appearance. You can also switch between HD and SD versions of planet skins if you have them installed. Now we'll adjust the planet atmosphere visuals. Rayleigh scattering affects the color of the sky. The inverse of the color is applied though, so a lower value for blue will result in a bluer sky. Scattering affects the sky color at sunrise and sunset. Setting the color to be very different from the Rayleigh color can result in some very vibrant skies. We can adjust other visual parameters on this page, including atmosphere thickness and sunlight color. There are also controls for air density, oxygen density, and wind speed at the top. While the cosmetic atmospheric settings can be changed on each spawned planet individually, the three functional values are shared between all planets of the same type. So for instance, all Earth-like planets will have the same air density value no matter what. Now that we've modified the atmosphere, you may notice that the proxy's atmo doesn't seem to match it anymore. This will make things look strange when entering or leaving the planet's zone. So let's fix it. I think that ring color could use a bit more work. Let's add a moon for this planet. In terms of hierarchy, there is no real difference between any of the body types. You can set a star to orbit a gas giant which orbits a terrestrial planet if you want. We'll put a particle on this one. There, now it looks like the atmosphere is being stripped away. We can also change the day length. Flashing lights warning. The faster a planet is spinning, the more velocity will be imparted to grids leaving the surface. You can also set the period to 0 to disable rotation, or a negative value to have it spin the other direction. If you set the rotation period and orbit period of a planet to the same exact value, then the planet will be tidally locked to its parent. This means that the same side of the body will always be facing its parent, just like our moon. That's probably too extreme. Let's change some other things. Let's add another particle to augment the ring. It's easier to adjust the ring to match the particles if you want to line them up. Might need a bit more tweaking, but let's move on for now. All right, let's add another gas giant. The default 1 and default 2 gas giant skins can be tinted with the planet color setting. All of the other skins have static textures and can't be tinted. The vibrant skins are part of the optional mod we added at the start. Let's go with this one. The planet color setting will also affect the gaseous particle effect inside the planet, even if the planet's skin isn't tintable. So let's adjust that manually to match. This one also needs a ring. Looks good for now. Let's add another moon. Some of these are too small. We'll try upscaling a few things. Back to the alien planet for now, and we'll take a look at adjusting its gravity. We can fine-tune the gravity wells if we turn on the gravity helpers. Gravity strength affects how strong gravity is at the surface of the planet. Gravity fall-off affects how quickly the gravity fades out. A value of 7 is the vanilla default. A value of 2 is realistic gravity. Lower values make the gravity well larger. Looks all right for now. Let's go back to the alien planet. Let's add an empty zone this time. Empty zones function the same way as any other planet or star in the hierarchy, but do not have an actual body at the center. They can be good for making things like asteroid fields or nebulae. Let's make this one a debris field. We can add effects to the space with a functional zone. Functional zones define special areas that can apply effects to players and grids inside them. Things like weather, damage, resources, gravity, etc. Let's add some resources. This allows ores to be collected with collector blocks within the region. Planetary rings can give resources the same way. Resources are configured as a weighted list. A higher number means the ore will drop more often compared to the others. The ring amount or resource amount values control how much ore will be collected. Now for some weather effects. Particle effects, fog, and ambient sounds can be configured to appear while inside the region. Let's start by setting the weather's main particle effect. We can add a little fog on top of that. Density controls how close the fog looks to the camera. Multiplier controls the overall thickness. Skybox controls how much the fog will obscure the skybox. Atmo controls how much it will cover everything else. Color is the color of the fog. For most cases, all of the fog control values should stay between 0 and 1. And we'll hook up some ambient sounds as well. Next, we should add some resources to the rings. Let's make the planet more interesting with a functional zone. The affected region setting controls what subzones are affected. This one is on the planet's surface, so we'll set it to surface. Setting it to orbit would affect anything in the orbit region, and proxy would affect anything in the empty space between bodies. The also affects toggle can be used if we want a zone that applies to both the orbit and surface regions. Let's try a cone shape and have it always face the light. That way, the zone will affect anything on the day side of the planet. Now for some snowy weather. When adding a weather effect, we can select from any of the listed presets and have all of the associated parameters automatically populate. Then we can adjust them manually to get the exact effect we want. And some wind to push things around on top of that. The turbulence settings create randomized wind that can push in any direction. Strength affects how hard the wind pushes. Scale affects how quickly the wind changes direction when moving through space. Shift applies an offset to the entire random wind field over time. Seed is the random seed that generates the wind field. The other wind settings can apply constant wind relative to the zone center. So you can have wind that always pushes down or east if you want. The weather options are similar to the other particle options. The main difference is that the weather system creates multiple particle systems based on the spawn molt value. They are spread out randomly over a range according to the radius value and angled according to the tilt angle value. The threshold settings are another important part of functional zones. Each zone will affect grids and players proportionally to the zone effect at their position. The min and max thresholds for each effect will control the minimum zone effect required for the effect to start fading in and the value required for it to reach its maximum strength. You can use these to stagger the introduction of new zone effects as you approach the center of the zone. For instance, you could have a weather effect start to fade in at the edge of a zone, some resources become available a bit further in, and have some damaging effects that only apply at the center. We'll add some oxygen to the zone and then remove the oxygen from the rest of the planet. Now players can only breathe during the day. Looks good for now. Let's take another pass on the black hole. It could use some more polish. Let's add a glow effect. The alien planet still looks a little plain. We'll put some space debris around this one. The render limit settings control where the particle system will be visible. If the camera is closer than the minimum range or further than the maximum range from the particle system, then the particles will not appear. We can use this to constrain particles around the planet to not appear while we are on the surface. The black hole could use some functionality. Let's add a new zone. You can get some interesting visual effects by setting some of the fog values to negative or larger than 1, but it may cause graphical issues. And we'll add in some damage for grids and players. In general, we should make sure that any functional zones do not extend beyond the bounds of their affected regions. We can use the helper tools to ensure that the zone isn't too large. The soft edge factor parameter controls how quickly the zone transitions from 0% to 100% effectiveness. A value of 0% will have no fading at all, while a value of 100 will set only the very center of the zone to be maximally effective. That should work for now. Let's add another star. If a world has multiple stars, then the sunlight direction will change depending on where the camera is and how bright each star is. The game does not support multiple global light sources, so you will see the light direction swing around as you travel between systems. However, the sunlight direction is restricted to only rotating around a single axis by the game engine, so going above or below stars will result in the light direction looking wrong. For this reason, it's best to limit the pitch and roll of planets so that the light direction doesn't look too askew on the surface. All stars will set grids on fire by default, so keep an eye on the damage radius setting. More particles, you know the drill. The enabled type options lets us set particles or functional zones to turn on and off over time. The random option generates a random value that moves between 0 and 100%. Whenever the value is less than the simplex threshold, the particle or zone will activate. Simplex scale controls how quickly the random value changes over time. Larger values will have it change slower. If use fade is on, then the particle or zone will fade in and out gradually as the value crosses the threshold. We'll add one more effect. And we'll have this one spin. Update period controls how frequently the orientation of the particle is updated. We'll set it to 1 to get nice, smooth motion. The random values generated for enabling particles and zones are technically pseudo-random, which means they are entirely deterministic. Anything with the same simplex seed and simplex scale will generate the exact same values at the same time. You can use this trick to create multiple things that turn on at random, but are synchronized with each other. That said, let's sync some functionality to the particles. Functional zones can be set to have a sphere, cone, or torus as their basic shape. The different shapes have different parameters to control their dimensions, like cone angle. You can also cut out the inner portion of the zone to make it hollow with the inner cutout parameter. Some of the field effects can be set to have either positive or negative values. The grid damage, airtight damage, annihilate, and reactor power modify are the only effects that cannot be set in either direction. We'll configure this one to recharge batteries and damage grids. And sprinkle some wind on top of that. We'll make a copy and flip it around for the other side. Let's put a planet here as well. We'll make the weather here last longer and affect the whole planet. And we'll add some moving particle rings. The particles with rotate in the name will orbit like this, but can be a bit finicky depending on the settings. And we can make a copy at a different orientation to get that double ring effect. Something else to note is the proxy scale parameter. This value controls how large the planet appears in proxy space without actually changing the size of the real voxel planet. This means that you can have a moderately sized voxel planet to land on and explore, but it can appear as large as a real planet from the outside. You could also make the planet much smaller in proxy space to create a mini solar system with shorter distances between bodies. This time we'll add a special object as a local attraction. Megastructures are definitely the way to go. Special objects like this can be added to any body or empty zone. They don't have any collision, but will repel players and grids by default to prevent anything getting too close to them. We'll add an effect so it looks a little more dynamic. Looks good. Let's make it only turn on occasionally. We'll have it appear for 5 minutes out of every 15. Let's take one more look at the siblings. Sibling weight controls the apparent mass balance between a pair of siblings. Setting one higher or lower will shift the center of gravity between the bodies and make one look heavier. However, the total distance between them will remain constant. This one looks odd floating out here, so we'll give it a parent. We'll take one more pass on the orbits to adjust their speed. Keep in mind that the lower the orbital period, the faster the body will be moving. If the body moves faster than the global speed limit, you won't be able to catch it without a jump drive if it's moving away from you. It also means you might gain a ton of speed when entering or exiting the planet's zone, so be careful to not make them too fast. And one more moon for good measure. But I think we'll put this one around the second star. You can shuffle around the bodies in the world however you want. So if you have a world you've put a lot of effort into building, but decide you want to change the hierarchy, that's no problem. Even a world with a lot of grids and voxel changes in it can be reshuffled at any time without issue, as long as you don't delete or respawn the voxel planets themselves. We're almost done. Now we can make some adjustments to the voxel planet positions to reduce physics precision issues. Many things about the game, including spawns from any MES mods, will start behaving poorly when the player is far away from the world origin. That is, the coordinates 0, 0, 0. So it's important to limit how far the actual planets are from the origin so that gameplay is more stable. What we need to do here is change the V-planet range min and max values, and then respawn every planet with the new range constraints. This will restrict the planets to a certain radius around the origin. For terrestrial planets, we can use 0 and 50,000. For gas giants, stars, and empty zones, 50,000 and 80,000. For anything with a particularly large radius or gravity well, you may want to spawn it even further away. The key is to keep the terrestrial planets close to the origin. but make sure that none of the true bodies are close enough to have overlapping gravity or zones. We also want to keep the true bodies away from the proxies, so we don't run into them by accident. Use the Mark True Bodies option to keep track of where the true bodies are, and the Show Gravity options to see the gravity wells. Also, keep in mind that using Recreate Planet will destroy the voxel planet and respawn it somewhere else. So make sure you do this step before you actually build anything in the world, or you may lose progress. One final thing you may want to set up is the spawn range for the space respawn pods. By default, the game will set the space respawn area based on a box drawn around all of the voxel planets. This may result in players being spawned far away from any of the proxies in the middle of nowhere, so you can configure a custom area using the editor. Now that that's all squared away, let's take a tour of our system. Thank you for joining me on this cosmic customization tour. I hope you now have a better understanding of the Real Solar Systems mod and some of the ways you can use it to build interesting systems. If you have any specific questions or just want to show off your creations, feel free to join the Discord linked in the description. I'll see you next time.